Welcome all to discuss another groundbreaking achievement in space exploration. New Horizons is a NASA mission to study the dwarf planet Pluto, its moons, and other objects in the Kuiper Belt. The New Horizons spacecraft explored Pluto and its moons in 2015. In early 2019, New Horizons flew past its second major science target, called Arrokoth, the most distant object ever explored up close. Let's look at some details of this superfast New Horizons spacecraft. This spacecraft nation is United States of America, USA. Spacecraft objectives are: first, exploring Pluto flyby. Second, Kuiper Belt object flyby. Spacecraft mass is 1,054 pounds or 478 kilograms. Mission design and management by NASA and Johns Hopkins University Applied Physics Laboratory. New Horizons spacecraft launched by Atlas V, 551 rocket from Cape Canaveral, USA. New Horizons spacecraft included scientific instruments are: 1. Ralph Visible and Infrared Imager or Spectrometer. 2. Alice Ultraviolet Imaging Spectrometer. 3. Radioscience Experiment, REX. 4. Long Range Reconnaissance Imager, LORI. 5. Solar Wind and Plasma Spectrometer, SWAP. 6. Pluto Energetic Particle Spectrometer Science Investigation, PEPSI. 7. Student Dust Counter, SDC. New Horizons was part of NASA's New Frontiers program. This project made history as the first spacecraft to approach Pluto, a celestial object with origins dating back to the early days of the solar system. During its journey, the spacecraft traveled longer and farther than any previous deep space mission, spanning over 9 years by the time it reached the Pluto system. The design of the spacecraft was based on a lineage traced back to the Contour and Timed spacecraft, both also built by the Applied Physics Laboratory at Johns Hopkins University. Besides its suite of scientific instruments, New Horizons carries a cylindrical radioisotope thermoelectric generator that provided about 250 watts of power at launch, but it's decaying to 200 watts by the time of the Pluto encounter. After starting its journey, New Horizons first circled the Earth, at an orbit about 105 by 130 miles. Then, the Centaur upper stage of the rocket fired again for 9 minutes. This additional boost propel led the spacecraft to an oval-shaped orbit, extending all the way to the asteroid belt in space. A second firing, of the Star 48B solid rocket accelerated the spacecraft to a velocity about 36,400 miles per hour, or 58,536 kilometers per hour, the highest launch velocity attained by a human-made object relative to Earth. On June 13, 2006, New Horizons had a fortunate opportunity to test its instruments, particularly Ralph, which is a visible and infrared imager and spectrometer. During this test, the spacecraft passed near a small asteroid called 132524 APL, at a distance of about 63,300 miles. This allowed scientists to assess and ensure the functionality of the spacecraft's equipment in a real space environment. On February 28, 2007, the spacecraft passed close to Jupiter, the largest planet in our solar system, using its gravitational pull to gain speed. This maneuver boosted the spacecraft's velocity by about 9,000 miles per hour or 14,000 kilometers per hour, effectively reducing the time it would take to reach Pluto by 3 years. During the flyby, New Horizons carried out a detailed set of observations over a period of 4 months. These observations were designed to gather new data on Jupiter's atmosphere, ring system, and moons like Galileo, and to test out New Horizons instruments. Although observing the moons from distances much farther than Galileo, New Horizons was still able to return impressive pictures of Io, including eruptions on its surface, Europa, and Ganymede. After the Jupiter encounter, New Horizons sped toward the Kuiper Belt, performing a course correction on September 25, 2007. On June 28, 2007, the spacecraft went into a sleep mode called hibernation. During this time, the onboard computer continued to monitor the mission systems. It sent specific codes to indicate whether everything was going as expected or if there were any issues. On December 6, 2014, the team on the ground woke up New Horizons from its sleep mode for the last time to start its active exploration of Pluto. It took about 4 hours and 25 minutes for the signals from the spacecraft to reach Earth. From January 15, 2015, the spacecraft began moving closer to Pluto, adjusting its path with a short burst from its thrusters. 2 days later, New Horizons reached Pluto. By April 29, 2015, photos of Pluto started revealing clear features, and as the spacecraft got closer, the details became more apparent each week. On June 29, 2015, a final 23-second engine burn accelerated New Horizons toward Pluto by about 11 inches per second and adjusted its course. However, on July 4, 2015, there was a concern when New Horizons entered a safe mode due to a timing issue in its command sequence. Luckily, by July 7, the spacecraft returned to its normal science operations. Just 3 days later, data from New Horizons provided conclusive answers to one of the fundamental mysteries about Pluto. It is size of Pluto. Scientists determined that Pluto is approximately 1,470 miles in diameter, slightly larger than previous estimates. Additionally, its moon Charon was confirmed to be about 750 miles in diameter. Besides collecting data on Pluto and Charon, New Horizons also observed Pluto's other satellites, Nix, Hydra, Kerberos, and Styx. The information gathered by New Horizons revealed that Pluto and its moons were much more complex than scientists had imagined. They were particularly surprised by the level of activity on Pluto's surface. The atmospheric haze, and a lower-than-predicted atmospheric escape rate led scientists to rethink their earlier models of the Pluto system. Pluto shows signs of significant changes in atmospheric pressure, and there are indications that it may have had liquid substances on its surface in the past. There are even hints that Pluto might have an internal ocean made of ice today. The spacecraft captured stunning images, including a massive heart-shaped glacier made of nitrogen on Pluto's surface, named Sputnik Planitia after Earth's first artificial satellite, Sputnik 1. This glacier is about 600 miles wide and is considered the largest known glacier in the entire solar system. On Charon, Pluto's largest moon, images revealed a huge belt in the equatorial region, suggesting the possibility of a past water-ice ocean on Charon's surface. After exploring Pluto in the fall of 2015, the mission planners decided to change New Horizons' course for another adventure. On January 1, 2019, the spacecraft conducted a flyby of a Kuiper Belt object called 2014 Mu-69, located around 4 billion miles away from Earth. This object was later called Arrokoth. The goal of the encounter was to study the surface geology of the object, measure surface temperature, map the surface, search for signs of activity, measure its mass, and detect any satellites or rings. On April 3, 2017, New Horizons was halfway between Pluto and its next target. Shortly after, on April 10, the spacecraft went into hibernation mode, remaining unpowered for a long summer's nap until September 11, 2017. During this time, the flight computer sent a weekly beacon status tone and a monthly data stream on spacecraft health and safety back to Earth. On the anniversary of its Pluto-Charon flyby on July 14, 2017, the New Horizons team unveiled detailed maps of both planetary bodies. Then, on January 1, 2019, New Horizons successfully flew past Arrokoth, marking it as the most distant target ever reached. Initial images suggested a reddish, snowman-like shape, but closer analysis of images taken from just 2,200 miles away revealed the truly unusual shape of this Kuiper Belt object. Arrokoth, the distant object, has a unique shape, measuring about 22 miles long, 12 miles wide, and 6 miles thick. The larger lobe is lenticular, flattened like two lenses back-to-back, with dimensions of approximately 14 by 12 by 4 miles. The smaller lobe is more rounded, measuring about 9 by 9 by 6 miles. Principal investigator Dr. Alan Stern from the Southwest Research Institute in Boulder, Colorado, remarked that this shape is unprecedented in the solar system, challenging scientists to rethink how planetesimals, the building blocks of planets, form. New Horizons remains healthy in the Kuiper Belt, moving away from Earth and the Sun at a speed of about 300 million miles per year. It entered hibernation mode on June 1, 2022, and will stay in hibernation until March 2023, to conserve fuel and reduce wear on the spacecraft. In April 2022, its mission was extended once again, possibly for additional observations relevant to the solar system and NASA's heliophysics and astrophysics divisions. So, we are thankful and hope New Horizons spacecraft remain healthier for our future observations. If you are interested, hit the like button, comment and subscribe.